Hello friends, welcome to video number 25 or question number 25 of data structures and algorithms practice group by Akshaya and Nim. Let me just introduce those people who are new to this about the group. So basically you must be seeing a link below for data structure and algorithm practice group. In this group regularly questions are posted and presently we are on question number 25. Questions are posted which students can practice by themselves, they can try by themselves. If they get stuck or have any doubts, they can post there and they are reverted with the doubts so that they can do it by themselves. And in the case if they are not able to do it by themselves, okay, I have set a time limit of maybe 24 hours. The solution like this video is posted, right? So data structures and algorithm mastery practice mastery can help you crack great tech giants like Amazon, Microsoft, and help you earn great packages like 12 to 30 lakhs INR per annum in India and 100 to 200k US dollars if you're working outside, right? And that is possible even if you are a fresher, even if you don't have a degree, even if you don't have an experience, right? The only thing that matters is whether you are a problem solver and can you demonstrate in the interviews that you can do data structure and algorithm practice, right? And I myself am Akshay from IT Delhi, BTech Computer Science, having worked with companies like Amazon, Paytm, and have trained students who are working at companies like Microsoft and Paytm, right? So you can click on the link, join in the group and do the practice so that you can master these data structures and algorithms. So now let's jump on to question number 25. This question is fairly simple, it's fairly straightforward. Okay, you can maybe pause the video right now and try this question by yourself also if you have not already done so. Okay, the question is easy, yet I chose to include it over here for two reasons. One reason is that for a while I had been observing that the questions were pretty much tough or people are not able to do the questions because they had been feeling low. So I thought let me just introduce an easy question, right? And second thing is each and every question actually teaches us something, right? Which is fairly correct, right? But the main reason about this is this question actually made me reinforce the principle which I always ask other students to follow. Okay, so as you will be seeing even in this video, and if you have been following all the videos till now, I embed the videos with a lot of interview tips, a lot of interview sites, a lot of tricks, a lot of ideas about how to solve data structures and algorithms problems, how to do problem solving, right? How to prepare for interviews. So in this video, in this question, I realized that the question is reinforcing a principle which I already shared, right? And I also learned it the hard way because see, we all are humans and it is always possible for us to forget certain principles, and because of that it can cause us to spend a lot of time on solving problems, right? Obviously with practice the amount of mistakes that you're going to make will reduce and you're going to follow a certain pattern, right? And when you're going to follow these proven principles which help me crack almost all the interviews which I went for and help my students also successfully clear those interviews, when you follow the proven principles, proven strategy, you can very easily master data structures and algorithms in the shortest possible time, right? So this question also reinforced one of those principles. Okay, one principle that even simple questions teach us a lot of things if you can just magnify upon them and try to see how you actually solve the problem. And second one, the principle which I am going to share in a while. Okay, meanwhile you can try the question by yourself or continue watching. Great. So this is the question, number of steps to reduce a number to 0. Okay, so let's see what the question says. Given a non-negative integer num, return the number of steps to reduce it to 0. Okay, if the current number is even, you have to divide it by 2, otherwise you have to subtract 1 from it, right? So the question might seem fairly obvious right now, but as always try to take examples and try to spend a good amount of time to be sure that you understand the question properly, right? So basically you are being given a non-negative integer num, and what you have to do is you have to reduce it to 0, right? And there are two steps, two ways of reducing it to 0. One is that if it is an even number, you must divide it by 2, and if it is an odd number you subtract 1 from it, right? And when you subtract 1 from it, it will become an even number, or it may become 0. Great. So let's see some examples also which they have shown. So the input number is equal to 14 and the output is coming as 6. Let's try and see how. So when the number is 14, as a question is given, for even numbers you have to divide it by 2. So when 14 is a number, dividing it by 2, we get 7, right? Then 7 is odd, then what we will do? We'll subtract 1 from it. That's why we'll get 6, and 6 again even, so we can divide it by 2 and we will get 3, right? 3 is odd, so subtract 1, you will get 2, 2 is even, right? So divided by 2 you get 1, 1 is odd, subtract 1 and obtain 0. Great, very simple technique. Similarly, when it is 8, which is 2 to the power 3, you can directly say the answer will be 4, right? Because that's the number of times you're going to divide it by 2, and eventually you will reach 1, right? And from 1 to 0, there's one step, right? So 8 is even, you divide it by 2, you get 4, 4 is even, you divide by 2, 2 is even, 1 is, and so on, you will eventually get 0, okay? Fairly easy. Okay, so the mistake I did in this problem was that though I was doing it on paper, I thought, why not let me just try and get the best answer possible, right? And when I say best answer, I thought, let me find the solution which is able to solve this question in the minimum space and time complexity, right? And I thought maybe I can just create a formula out of the numbers. I can create a formula out of the numbers which can give me the answer directly in order one time, right? Fairly good idea, because I thought there could be a pattern in this problem, right? So as I always say, try examples. So I did try examples. I wrote a lot of examples on paper, and being mathematically inclined, I tried to find a pattern in these numbers, right? So I wrote 1 and I found that for 1 I need 1 step. Then I wrote 2. For 2 I realized I need 2 steps. Then for 3 I realized I need 3 steps, and so on and so forth, right? I try to create a lot of patterns in this, right? For example, I realized that whenever number is a power of 2, whenever a number is a power of a 2, okay, let me just type it down and show it to you. Okay, so whenever a number is a power of 2, let's say 2 to the power n, I can be sure directly, without any computation, I can tell that this will be done in n plus 1 steps, right? And this can be proved very easily mathematically also, but let me just demonstrate a simple way of doing so. So you know, for 1, the number of steps which will be needed to do it will be 1. Why? Because you just have to subtract 1 from 1 and you will get, right? So in 1 step it will be done, right? Now for 2 we will reach 1, right? And for 1 we have to subtract 1. So as a result, when we have 2, the number of operations will be 1 more than the number of operations of 1, and as a result this will be 2. Great. Then I thought, if we have the number 4, I can divide it by 2, I will reach 2, right? And the number of operations for 2 to reduce to 0 is 2, right? And I am dividing 4 by 2 also. So as a result, I can directly say this, that 4 will take one operation more than 2, which is 3, right? Similarly, 8 will be there, right? And for 8 it will be 4, right? Similarly, in this way you can use mathematical things to prove that this is always going to be true. Okay, great. And then I realized one more thing. I observe another pattern. Okay, though eventually I found that these patterns are not useful at all. I will share that as the video progresses why. So another pattern I observed was, if a number is of the form of, if the number is of the form of 2 to the power n plus 1, okay, like for example, if we have the number 3, right? If we have the number 5, 2 plus 1 is 3, 4 plus 1 is 5, 8 plus 1 is 9, right? This can be, and this is also fairly obvious, right? This can be done in number of operations as n plus 2, right? So everything is actually very obvious when you observe it. The key hard work or the key value lies in being able to discover it, able to discover the pattern, right? So I found that okay, if a number is of this form 2 to the power n plus 1, it can be done in one more operation than the 2 to the power n, right? Because obviously you have to just subtract 1 from this number, you will reach here, right? And this you already know can be done in 2 steps. 5 minus 1 is 4, 4 can be done in 3 steps, right? So you simply have to add 1 to it, right? So if a number is of this form, it can be done in n plus 2, right? Then I took more examples. That is, I try to find the same thing for other numbers like 3, right? 2n plus 2, right? 2n plus 3, 2n plus 4. I observed a few patterns also, right? For example, for certain numbers I was observing, for example, I noted down on the copy also that I kind of try to build a triangle also, right? Okay, so it goes like this. One, then I'm just telling you the number of operations each number took. So for 1 we needed 1, for 2 we need 2, for 3 and 4 we both needed 3, right? For 5 and 6 we needed 4, and for 7 we needed 5, for 8 we needed 9. But then we saw that for 8 and 9 we took 4 and 5, right? For 10 and 11 we saw 5 and 6, right? For 12, 13 again 5 and 6, right? And 14, 15 we saw 6 and 7, right? So I was able to see some pattern is there, right? 4, 5, 6, 7, something like that. That is, the numbers were occurring in pairs, and probably the number of times each number is getting repeated might be a form of pattern also, right? So I was thinking like that, right? But I was failing. Eventually I spent a lot of time, but I could not figure out the exact pattern in this, right? So I thought, okay, I spent a lot of time in this, let me just get done with the problem and actually write a code and solve it. Okay, and then I recalled this principle which I always used to say, always used to teach my students, that always get your first solution running. Don't run after the best solution. Always get your first solution running, because one, maybe that's the best solution, right? Or maybe the interviewer or the online coding round is not really expecting you to write the best solution. They just want, it might be just a preliminary question to just write a basic solution, and the interviewer then might ask you to improve upon that, right? So thinking of that, I came back to the problem and I thought, okay, let me just do it the best, the simplest way, right? And after that I will think about it. Okay, so let's do the same thing here also. Let me just show you the answer also. The answer is pretty simple, which you must have already done. If not, it's okay, I will share the solution, and then I will share you that insight, the importance of getting the first solution, right? Why for getting the first solution helped me in this problem. Okay, so what's the simplest approach? The simplest approach is to follow the question. That is, if you're given a number n, if it is even, divide n by 2. If it is odd, subtract 1 from it, and keep on doing this till you reach 0, right? So that's what I did in the code. I have written down the code already, so let me show that the code to you also. So I'm maintaining an int count is equal to 0, which will basically measure or count the number of operations it took for me to reach from num to 0. Okay, so till the time num is not equal to 0, I will do this, and what I'm going to do is I'm going to count the operations. So whenever the code enters inside the loop iteration, I increment the count by 1, because whenever it is entering the iteration, it just means that operation of either dividing by 2 or subtracting 1 is happening once, right? So in this way I can count the operations, and then after that I just write simple if else statement, that if the number is divisible by 2, if it is even, divide num by 2, otherwise make else is equal to num is equal to num minus 1, and to the end you can return count. As simple as that, right? So this code works also, right? And as I always say, the advantage of doing simple problems is that you can magnify your understanding of the problem, and you can work on important things, right? So in this question you must definitely try to prove why this code works, right? Mathematically there is a way of proving this, right? Don't just do hit and trial and say that this works for 7, this works for 25, right? And don't just say that I am doing all the operations. You should be able to mathematically prove it, because you can never know otherwise, because otherwise you might be missing on to certain cases which will be coming to the surface or to your awareness only when you do it step by step in a mathematical proof, right? So make sure you're able to mathematically prove it. If not, then definitely join the courses, right? The paid courses I have, and there you will learn how to be able to do so. Okay, so let's come back. Let's assume that we have mathematically proved this code works as well, right? So what is the time complexity of this question? The time complexity is fairly very easy. The time complexity, can you tell? Just comment below without looking at the solution right now, without looking through the video. Just by looking at this code, comment below the time complexity of this problem and also write down your explanation for it, your reasoning for it. How did you come with it? Okay, I believe you wrote down the time complexity, and it is okay if it is not the same as mine, right? It is okay because everyone makes mistakes, but just have that confidence to say what your answer is and then work on it if it is not right. Okay, so the time complexity of this is going to be log n to the base 2, which is same as log n. Okay, now let's try and see how I can say that. See, when you are given any number, right? When you are given any number, how many times are you going to divide it by 2? Given any number n, the number of times you are going to divide it by 2 is going to be maximum the number which is the smallest number which is greater than n and which is the power of 2, right? The number of, for example, let's say we have the number 13. The number of times we will need to divide 13 by 2 would be less than or equal to the number of times we need to divide 16 by 2, right? 16 we will go to 8, 8 will go to 4, 4 will go to 2, and 2 to 1, right? Similarly, for 13 we might have to subtract 1, we will get 12, then we will divide 12 by 2, become 6, 6 by 2, 3, 3 we will make 3 minus 1, 2, then divide 2 by 1, right? But the number of divisions by 2 can never be greater than 16, right? Similarly, if you take 25, the number of times you can divide by 25 by 2 will always be less than the number of times 32 can be divided by 2, right? Because if you can divide 25 by more than the number of times you can divide 32, then 25 will become greater than 32, right? Because the power of 2 raised, let's say 2 to the power x is equal to 25, and x is greater than y, where 2 to the power y is equal to 32. This basically means that this is a contradiction. Why? Because 25 is less than 32 but x is greater than y, right? So the maximum number of operations for dividing any number by 2 would be same as log n, right? So log 25 will be the maximum number of times you are going to divide by 2, right? What is the second kind of operation which is possible? The second kind of operation which is possible over here is subtracting 1 from it, right? So what is the maximum number of times you're going to subtract 1 from it? The maximum number of times 1 can be subtracted from a number will actually be the same as the number of times you're going to divide it by 2, right? Maybe plus minus 1 of that, but it's going to be around that only, right? In the worst case scenario, maybe even not actually being possible, but in the worst case scenario, every time you're dividing by 2, you had to probably subtract 1 before that, right? And that might actually happen when you are probably dealing with a number which is 2 to the power n minus 1, right? For example, let's say we have 15. Okay, so let's take the example of 15 and see what can be done for the example of 15. Okay, so let's say we have 15. So for 15, what will happen after this? We'll have to first convert it into 14, right? And when we have 14, it must be converted to, it can then be converted to 7, or let me just write it over here. It can be converted to 7, right? Now 7 must be converted to 6, right, because 7 is odd. Then 6 will be converted to 3, right, and 3 will be converted to 2, and then 2 will be converted to 1, and then 1 will be converted to 0. Great. So how many operations? 1, 2, 3, 4, 5, 6, 7. It took me 7 operations, right? And let's say if we had 16, right? 16 is 2 to the power 1, 4, 8, 16, 2 to the power 5. Is it? Okay, let's just do this also. Okay, for 16 you will reach 8, and then we will reach 4, right? Then we will reach 2, and then we will reach 1, and then we will reach 0. Great. So number of operations 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Right. Great. So basically you can see that every time you're dividing this number by 2, you're always missing that number, right? 15 missed 16, 7 missed 8, 3 missed 4 by one number, right? 1 missed 2 by one number. So you cannot do the number of divisions in this more than the number of division that you are doing in this, right? If you take this number, the number of divisions by 2 will always be less than the number of divisions in this, right? Or let's just take it's exactly the same, right? And each number will be subtracted by 1 also. And how many times 1 will be subtracted? It will be subtracted each time after dividing by 2, or maybe before dividing by 2, right? And that is also going to be plus 1 minus maximum the number of time of divisions, right? So because of that, I can for sure say that whenever a number is given, either it is being divided by 2 or 1 is being subtracted, right? These are the only two operations. And if the maximum number of times a number can be divided by 2 is going to be log n, and that is a maximum time a number 1 will be subtracted, because when we are divided by 2, there are two possibilities. Either we will directly divide by 2 and reach to the next number, or we will subtract by 1 to make it capable of dividing, right? So this subtracting of -1 will be one extra step. And let's say this extra step is being performed after every division by 2, right? Because of that, maybe the number of operations will become log n plus log n, right? This second log n because of -1. And because of that, the total number of operations will become 2 log n, which is the same as complexity log n, right? So very beautifully, the time complexity is this. Okay, great. When I did this, and when I came across this is a complexity, I was in the back of my head thinking that probably now I should try a better solution, right? But then I realized one special thing about this question, right? So let's say even if I could find a pattern, uh, right? Even if let's say I could have found a pattern in this question, that is something like which I showed earlier, that if the number is 2 to the power n, the number of operations taken would be n plus 1, right? If the number is 2 to the power n plus 1, the number of operations are now going to be n plus 2, right? Similarly, maybe let's say there are other patterns also, right? But the problem is, to be even, let's say the other number is of this form, 2 to the power n plus maybe 2 to the power n minus 1, right? I could just find some patterns, but the problem is to be able to define this number, to be able to find the type of the number, I will have to perform log n number of operations. Okay, let me just explain to you once more. Let's say, let's try and represent the number in form of a binary number, right? So the number can be probably written as 1 0 1 1 0 1 0, right? Any number can be written in binary form, right? So when we are dividing by 2, we are basically taking the number from, we are basically removing the last digit, right? And when we are subtracting 1, again what we are doing is we are making it capable of getting the last digit removed, right? But the same problem will occur over there, that we will actually have to figure out all these digits. We will have to actually check when we are dividing by 2, right? We will have to check whether the last digit is 1 or 0. When we are dividing this number, we will have to check, let's say we converted this also to 0, right? Again we will have to check whether this number is 0 or 1. Then when you remove this, we'll again have to check whether this number is 0 or 1, right? So we will have to ask lot of if else questions to identify what the number is. And because of that, I will have to perform the number of operations of at least log n length, right? The length of this number is going to be log n, where n is the number, right? So I cannot really escape the log n time complexity, and that's why the worst solution or the simplest solution which I just did, the code which I just did of following normal operations, that is divide by 2 or doing minus 1, is the best possible solution, right? So that's why it just got reinforced for me, and I believe you should also now develop greater trust that always follow proven strategies, proven principles, because they are not only going to save you a lot of time, right, but will help you learn at a faster rate, right? Why reinvent the wheel unnecessarily, right? Why do you want to learn to how to create fire? Follow the principles, create that fire, and see that it's been created. Now probably try to understand it. Your understanding will improve, right? That's why we have books, that's why we have classes, that's why the teachers are there, because they are already educated and they can help you understand their own thoughts and you can adapt to them, right? And that's why I would urge all of you, if you're not already part of the course, to hop in and join the courses and learn, because that can help you master data structure and algorithm in less than a month or maximum 3 months if you actually give your best, right? My students have done that. My students have been able to do that in just 1 month period, right? They have been trying to do the practice by themselves, maybe 6 months or more than that. They have been trying, and when they came to me, I helped them learn that. And because they did the questions with intensity, because they did understand the principles, because I follow the proven strategy which helped me crack almost all the interviews I went for, after learning the strategy, after learning that formula, I was able to crack, and so were they, right? So definitely join in the courses, learn from them, and master data structures and algorithms, right? And keep following the principles. I hope you enjoyed the video, right? So click on the like button, comment below whether you were able to identify the time complexity correctly. Also comment below whether you have now more trust on proven strategies, and if you are going to join in the courses, right? Don't forget to subscribe and share with your friends. I will catch you in the next one. Bye bye and take care.